start. Mr. Bipul is ready for second session. So over to Bipul, sir.
Okay, thanks a lot, sir. Very good afternoon to everyone. Am I audible now?
Yeah.
Okay, that's great. Thank you, I welcome everyone and thanks a lot, sir. So we can continue our part. I hope you are not tired too much, right? So anyway, we'll take care of that. Just a minute, let me share my screen first. Okay. Okay, I guess my screen is visible to all of you, isn't it? My screen is visible to all of you, right?
Yes,
Yes,
it is
sir.
visible.
Okay.
Yes,
Okay, that's
but
great.
we
Okay.
can't see PPT.
No, I'm not having any PPT. Don't worry about PPTs, right? Okay. What we had seen in last class, we had gone through the part of NumPy, Pandas, the importance of some libraries, right? Today we will discover like how we can use them or how we can use it for different machine learning things and all, right? Like some data analytical process, some data analytical and data cleaning importance I had taught in last class using some data that was I guess some what was the data, it was like some supermarket data I used, I guess. I'm not sure, like it was some supermarket data that I used, right? Today I will just start with the part of explaining the machine learning according to the content that I'm having. Okay, so what I have to tell you about like what ML, okay, like many of you may be knowing it, okay, so I'll just make it little short. Okay, just a minute. Okay, I will make it little short. Okay, like what is machine learning? Okay, so what a machine learning is? Machine learning means it's like making a machine learn with the help of data and all. Okay, like with the help of certain experiences, with the help of past experience or past data, a machine will learn to make the predictions in future, isn't it? That means what can happen in future or what can happen next. Okay, that is the main, or you can say the one of the prime objective of machine learning, isn't it? Now if you talk about machine learning basically divided into three different categories. Okay, so out of that the first category is what? Supervised learning. Okay, what we call supervised. Also, yeah, right, supervised learning, right? So what supervised learning is like? That means you have to supervise someone. Like I'm supervising as of now, right? To make you learn something. So that what exactly I'm doing? I'm giving you some data. I'm giving you some data by speaking out. Okay, some verbal things I'm just speaking out, right? And that is basically giving you a data, and those data are getting stored in your brain. Okay, so that you can use those data in future to make some kind of a decisions and all. Okay, same way what we do, we supervise a machine to learn. Okay, and when we are supervising something, okay, what exactly we required? Okay, like if we have to, suppose there's a kid, okay, and we have to just supervise him to learn some kind of multiplication tables. Okay, so what we have to do, we have to just use this kind of things. Okay, so in this case, okay, in this case, what is it? These are your features. Okay, these are what? These are your features, and these are what? These are your labels, isn't it? So that means in the supervised learning, if you are making a machine learn through supervised process, through a supervised learning process, you need the entity in the data. Okay, the data should have two entity, very important. One is called features. Okay, features means what? Independent variables. Okay, and second is called what? Labels. Okay, labels means what? Dependent variables. Okay, labels are what? Dependent variables, right? Because they are depending upon independent variables. Okay, for example, we have to make a for example, I have to make a model to predict weather condition. Okay, like weather forecasting. Okay, so for weather forecasting, what can be the what kind of data can be used? Okay, there can be, the data can have this kind of nature. Okay, There can be multiple features, there can be multiple labels, right? But I'm just supposing there is a feature, like suppose there is a temperature I'm considering. Okay, I'm considering air speed, correct? And thereafter there is a label. Label means what? Weather condition. Okay, weather condition. Now, weather condition can be of, there can be a number of types that can be predicted. Okay, for a particular case, suppose I just want to make a model that can predict a rain, isn't it? So it means what? Rain. Okay, someday it is raining, someday it is not raining, someday again it is raining, someday again it is not raining. Okay, and these rains and these not raining conditions are dependent upon certain temperature and speed of air. Okay, according to my data. Okay, rain and not rain can be dependent upon so many things, but according to my data it is depending upon what? Temperature and speed of air. Okay, so in this case temperature and speed of air is what? These are basically our features. Okay, and these are our labels. Okay, so what we do, we just store the features in a variable x and label in y. Okay, and once we are having the variable x and y, we use a certain thing that is known as algorithm. Okay, we use algorithm with this particular data to develop something that is known as model. Okay, and that model will be used for what? For the future value prediction, like what can happen in future, what can be the future value output. Okay, so it is how things happens. Okay, now if we talk about this supervised learning, then it is just a definition. Like that means in the supervised learning, what we need two things that are called features and labels in a data. With the help of features and labels, we just make a machine learn. Now question is, why we need features and labels? Okay, because supervision always need the actual output. That means what? Just consider a case. Okay, a case where suppose you are a manager of a particular institution, of a particular company, of a particular organization, or you are team lead, you are leading some projects, right? You are leading a project, or you are a kind of a manager of certain activity. Okay, so in that case there will be a number of employees working under you. Okay, now what is happening, like they are doing certain tasks, then how can you say that okay, they are doing correct or they are doing incorrect way? Okay, they are basically doing the they are going on a proper path, or they are not following a proper path. Okay, you can say because you are already knowing all those things. Okay, because you are a manager, you are having experience, you know the actual output, you know the actual label. Okay, just give me 1 minute. Okay, so what I was saying, like you are knowing already those things, like what can happen. Okay, so based upon that, you can just if anyone does any wrong, you can correct him. You can just ask him to how to work and how not to work. Okay, so what are you doing? You're supervising. Okay, same way, let us consider one more case. Okay, suppose I had given a paper, I had given a examination. Okay, and I had given examination of suppose physics. Okay, so in that case, who can just check my answer sheet? Okay, who can check my answer sheet? The person who is knowing the actual answer can only check my answer sheet. Okay, and after checking the answer sheet, he can give me what? Marks. Okay, and that marks will show what? That marks will show my accuracy or my error value, whatever as I want to consider. Okay, like how much error I am doing, or how much accuracy that I am basically having as of now. Okay, so that means that is also reflecting my learning. Okay, that is also reflecting my learning, right? That means the examination, why I had given the examination, why a particular like kind of a student gives the examination to just check the accuracy level, isn't it? That will reflect his learning. Actually the same way, when a machine gets learned, what we need to check the accuracy of it. Okay, accuracy. Okay, why we need accuracy? If we are having accuracy, then we can decide that the learning is going in a correct direction or it is going in a wrong direction. Because if you don't have accuracy, you can't decide that learning is going in a correct direction or not going in a correct direction if you can't monitor. Correct. So that's why for monitoring, what we need labels. Correct. That means what? Suppose there is a condition like this. Okay, 3 plus 2 is equal to 5. Okay, 3 plus 3 is equal to 6. 5 plus 3 is equal to 8. Okay, 7 plus 2 is equal to 9. Okay, and 2 plus 17 is equal to 19. Okay, so in this case, just consider I am teaching this thing to a kid. Okay, so in this case, this will be what? These will be my features. Okay, and this will be my labels. Okay, thereafter what I'm doing, I just taught him, and thereafter I am just asking him to work without looking. I just hide this particular thing. What is it? The labels. Okay, so there can be two conditions. Condition one, okay, either the kid, okay, either the kid develops the logic, either the kid develops logic, okay, logic of these calculations, okay, or condition two, he just learned everything. Okay, he just learned everything. He had no logic, but he just learned everything. Okay, so these two conditions are there in machine also. Okay, in the case of machine also, these two conditions can be there. Okay, like a machine can develop a logic, okay, that how the things are going on, or a machine can learn. Okay, both things are there. Okay, so how can we say that, okay, it develops a logic, or basically it learns actually? Okay, so first of all, let us consider a very basic thing. Okay, very basic concept. First of all, we will not look into it. Okay, what we will do is we'll just train a model, we'll just train a kid, okay, anyone, and thereafter what we say, we just hide this particular level and then ask, just give me the answer. So I'll ask him what is 3 plus 2. He told me 5. Then I ask what is 3 plus 3. He is telling me 7. Then I ask what is 5 plus 3. He told me 8. Then I ask what is 7 plus 2. He tell me 6. Okay. Then I ask what is 17 plus 2. He told me 15. Okay. Then what I will do, I will take the differences. Okay. Differences, right? Now differences is what? 0 over here. 7 minus 6 minus 7 minus 1. 0. 9 minus 6 3. 19 minus 15 4. Take the mode of it. Okay, and then the average. Okay, so average will be what? It's 4 plus 4 8 divided by 5. Okay, so this is your average error. Okay, it is what? It is your average error, mean average error, right? Now it is a process of calculating the average error. Okay, so how can you calculate the average error if the labels will not be there? If I will not give you the information about it. If suppose a condition where I am not giving you the information about the actual values, okay, and you are also knowing it, you are also not knowing it. Okay, I am not giving you any information and you are also not knowing it, then can you calculate this thing? No, you can't calculate it. Okay, that's why in supervised learning the labels are important. Okay, with the labels we can evaluate what? We can evaluate the error. With the labels only, what we can do, we can evaluate the errors, right? So that is how supervised learning, that is the first requirement of supervised learning. That what is the first requirement of supervised learning? It should consist of features, okay, and labels. Okay, because labels will help you to evaluate the errors or the accuracy. Okay, now what is supervision over here? Okay, so let's discuss the supervision now. Okay, just a minute. Okay, what is supervision over here then? Correct, let's discuss the supervision now. Okay, so what we are having, if we are having a data sample, okay, that data sample consists of, suppose 1000 samples. How many samples? 1000 samples. Okay, then what we do, we divide this 1000 samples into two parts, major part and minor part. Okay, for example, major part is containing 800 samples. How many? 800 samples. And minor part is containing what? 200 samples. Correct. Now this major part will have what? Will have features as well as labels. This minor part will also have what? Features as well as labels. Correct. Now what we do, we will train our model, okay, not on both the data. Okay, we will train our model only one part of the data, that is known as training data. Okay, this part will be used for what? Training. Okay, This part will be used for what? For training. Training means what? Like we use algorithms over here, okay, and we'll try to train it. Correct? Now, if it is trained, so it will be trained using features and labels. Correct? After the training is done with the help of algorithm, thereafter what we will do? We will make the predictions over the features. Okay? We will make the predictions over the features. Okay? Predictions. Okay? And this prediction will be now compared with what? With labels. Okay? It will be compared. Okay? So when it will be compared, what will happen? You will get some accuracy label or error ratio, whatever, like how many times, what is the measure, what is the difference between it, and all those things. Suppose over here, if you compare it and your error values, the average error suppose came is suppose 5. Okay, average error is what? 5. Correct. So that means, anyone wants to say something? Just a minute. There are some chat message, I guess. Some other issues. Okay, so it will be compared and you will say suppose average error is what? 5. Okay, now you say that okay, my average error is 5. Now what you will do? You will go back to another side, that is testing data. On this testing data, you will not train. Again, I am repeating, you will not train. Okay, this data is not for training. This data is just for a what? Just for accuracy or error evaluation. Okay, now you evaluate it. Now what you do? Now again you make the predictions over it. Again you make the predictions over it without any training, because using the past model only, whatever the model that has been created over here, the same model will be used. Okay, whatever the model that has been created earlier, the same model will be used to make the predictions in this case. Okay, so when the prediction will come out, this prediction will be compared with this level. Okay, and then some accuracy or error level will come. Suppose error level over here is coming for around 4.7 or 5.2 or 5.5. That means it's okay. Okay, because over here the error level is 5. On testing data it is almost close to the actual error level that is on the training data. That means your model is good, it's working fine. Okay, that means you can trust, you can deploy, you can tell your the stakeholder that my model is basically behaving with accuracy, or you can say with a error, it is showing an average error, mean absolute error of 5. You can just tell him that it is showing mean absolute error of 5. Okay, whatever the data that you had given, okay, using that data I trained my model using some algorithms, and this is the error level that I am getting. If you want to make it more good, okay, you want to make it more better, either you can just give me more data, or you can just try with some other persons, like this is what that I'm getting at best. Okay, next, it is what? It is a condition one. Okay, where what happened, where the things were like you are getting almost same kind of things. Okay, the condition one was what? Like it develops the logic. Okay, your model develops the logic. Condition 2 is like here the error level is 5, but here it is coming suppose error 15, average error 15. It shows what? It shows that your model had worked very well on the training set of data, okay, but it fails on unknown values. But it fails on unknown values. That means your model is not so much good, okay, in the case where unknown values had been given to it. Okay, but when known value has been given to it, it had so very high accuracy or low error. Okay, but when unknown value came into the path, okay, it just fails out. Okay, and that is called what? That is known as your overfit model. Okay, that is known as what? Overfit model. And that's why we need what? Supervision. Okay, or if in case in both the cases the error is very high, suppose here also it is 15, here also it is 17, 15, then also we need what? Supervision. Okay, then also we need supervision. So what we concluded that supervision is only possible if this entity is present with the feature. If this label is not present, then at any point of time you can't evaluate any error. You can't evaluate any error, and without evaluating any error you can't supervise. Correct, you can't supervise, right? Now with this supervision, supervised learning, supervised machine learning, we are having two things. Okay, there are two parts of it. What are those two parts? Those two parts are, first is known as classification, okay, and second is known as what? Regression. Okay, so what is classification? Classification is a process. Okay, classification is a model building process where we develop a model, a machine learning model, in such a way that a categorical prediction can be made. Okay, categorical prediction means what? Categorical prediction means, suppose I have to develop a model for weather forecasting. So weather can be what? It can be rain or it can't be rain. So categorical prediction means what? Rain, okay, or not rain. That means your model is predicting that will it be a rain or it is not going to be any rain, right? Like, will it be profit or it is going to be loss, correct? Will it be like salary will increase or it will not increase, okay? So these are what? These are your categorical prediction, right? Next is called regression. In case of regression, model predicts a continuous value. Okay, it is basically developed. We create it to make a continuous value prediction. What is continuous value prediction? Basically, continuous value prediction means, what is continuous value prediction? It means, for example, if it is raining, then how much rain? How much rain, right? Like how much centimeter of rain? Okay. Profit, then how much profit? Okay. Loss, then how much loss? What will be the stock value? What can be the stock value? Okay, or stock price? Okay, so here these things can't be categorized. Okay, profit or loss can be categorized. Okay, but how much profit you can't categorize. That can be any number. That can be 70, that can be 75, that can be 25, that can be 32, right? So it can be any number, 32.7. Okay, so that means these are the regression where a continuous value can be predicted. That can be a decimal value as well. But in classification, we predict what? It can be just a categorical prediction. Okay, that means something is profit, loss, what is this? Increase, decrease, rain, not rain, right? So these are two types of supervised learning processes. Okay. Now, if you discuss a supervised learning process, we have to discuss both of these things. So first we will consider the classification and next we will consider the regression part, right? So let's consider the classification part. Okay, so if it is a classification, okay, then classification needs certain algorithms. Okay, classification algos. Okay, there are certain algorithms behind classification. What are those classification based algorithms? Okay, so let's discuss it. There are certain classification based algorithm. Out of those, certain are very popular. Okay, like one of the very popular algorithm, okay, that works very good in so many cases are known as KNN. Okay, that is k neighbors classifier, okay, or k nearest neighbors. Then we are having what? Second thing, that is decision tree classifier. Okay, decision tree classifier. Okay, then we are having something called support vector machine. Okay, or we can have what? We can have random forest. Okay, random forest. Okay, so, or anything else, we can have XGBoost is also there. XGBoost. Like, so there are n number of things that you can get. Like there are almost 28 to 30 algorithms are there. Okay, so it depends like in which algorithm you are good or what algorithm you want to use. Maximum if you are knowing 5 or 6 algorithms, so you can solve any problem. Okay, if you're knowing 5 or 6 algorithms, then any problem can be solved. It is not like that all the algorithm you should know, right? The 5, 6, 7 algorithms if you're knowing, then you can solve any problems, right? So let's discuss one by one these algorithms, okay, and then we will deploy it, right? So we are having what? We should know about the KNN algorithm, right? KNN means what? K neighbors classifier. So what is K neighbors classifier? Okay, or K nearest neighbor. Okay, so K nearest neighbor is basically a very successful algorithm, okay, that is used for the classification processes. How it works? It works on the concept of distance formula. Okay, which distance formula? The Euclidean distance formula. Okay, it works on the concept of distance formula. It works like this. For example, you are having some data samples. Okay, so these are the crosses. Okay, now let's consider something else. These are the circles. Correct. Now, these are two different types of data samples that we are having. Now, if a new data sample came into the picture, suppose this is a new data sample came into the picture. Now the question is, what is it? Is it a cross or is it a circle? Okay. These data samples are having the features. Okay. These data samples are having some features like 3, 7. Okay. 2, I'm just giving you some random values. 2, 8. Okay. 3, 9. Okay. 7, 2, 5, 1. Okay. 7, no, 2 I had given 7, 7 set. I gave 7, 7. Okay. Actually, over here the coordinate I'm using, but if you see the coordinate, it will not get so much relatable. But don't worry, I'm just giving some random value just to explain. Okay, don't take it so much kind of literally that okay that how 3, 9 can be here and 3, 7 can be here. Okay, so don't take it so literally, right? So anyway, it is just like some features had been there. 6, 1, 6, 7, 2, 2. 3, 3. Okay, so they suppose these are having these different samples are having certain features. Okay, features are basically arranged like this: 7, 7. It is a circle. Okay, 7, 7. It is a circle. 5, 1. It is a cross. Okay, so it is like this. Now a new things came into the picture, and now he is asking, who am I? Am I a circle or am I a cross? Okay, so how KNN will help him to find its existence? Okay, what KNN will do? KNN will start calculating its distance from all the existing points, isn't it? Like how many points we are having? 10 points. So KNN will start calculating its distance from all the existing points like this. Okay, distance 1, distance 2, distance 3, distance 4, distance 5, distance 6, distance 7, distance 8, distance 9, and distance 10. How many distances? 10 distances. Out of 10 distances, KNN means K. Okay. The value of K. Here you have to decide what will be the value of K. Okay. Suppose you have given the value of K, or you are deciding the value of K to be 5. Okay. So what it will do, out of 10, it will consider, KNN will consider 5 nearest. Okay. So these are the 5 nearest. Okay. So out of 5 nearest, 3 are circle. So this thing will be labeled as circle. Okay. This thing will be labeled as circle. Right. So it is a simple concept of KNN, that is distance. Okay, like I ask you certain question. Again, what you did, you just start asking your neighbors. Okay, and out of all the neighbors, what you did, you just you are choosing the nearest 3 or nearest 5 or nearest 4 or nearest 7. Okay, to decide your answer. Okay, so that is how KNN works. Now question over here, what distance formula it is using? It uses a distance formula called Euclidean distance formula. And what is Euclidean distance formula? Euclidean distance formula is like this. If this is 0.1, okay, just a minute, it is 0.1, it is what, 0.2, okay, and you have to calculate the distance between it, right? How can you calculate the distance between it? It is having a coordinate x1, y1, it is having a coordinate x2, y2, okay, x1 minus x2 whole square plus y1 minus y2 whole square. Correct? So it is a distance. Correct? It is a distance formula that is known as Euclidean distance. Okay, why Euclidean distance? Because Euclidean distance can only give you the nearest point between nearest distance. Okay, for example, if there is a point like this, x1, y1, okay, x2 and y2, and you have to calculate the distance. Now if you use a distance formula like this, x1 minus x2 plus y1 minus y2, okay, so it will not give you the nearest distance. Okay, it will give you a distance like this. Okay, some distance like this. Okay, you want this one, the nearest one. Okay, and to figure out the nearest one, what you have to do, you have to do like this: x1 minus x2 whole square plus y1 minus y2 whole square. Okay, and thereafter, based upon all the distance calculated, nearest 5 will be considered, and nearest 5, 3, 4, whatever, it depends upon the case, it depends upon the different problem statement that we will figure out. Okay, based upon the problem statement, we decide what can be the distance, and based upon that, decision can be made. Okay, that is how your KNN works. Okay, next come the decision tree classifier. Okay, so let me explain quickly decision tree classifier, and then we will apply both of them all together. Correct. So next is your decision tree classifier. Okay, so what is decision tree classifier? Okay, so in the decision tree classifier, actually the decision is basically made on the tree classification. Tree classification means what? Your data sample will be collected somewhere like this. This is what data sample. Okay, and then it will start dividing itself into the tree shape structure. Correct? Tree shape structure based upon certain condition. Okay, and that tree will help you in making the decisions. Okay, will help you in making the decisions. Correct? So how it will help you? So let us consider some case. Okay, a simple case study. For example, I am having a data. Okay, let us define a data value. Okay, so I'm having a data, right? In this data, we are having something called over here result. Okay, and over here, suppose it is assignment and it is attendance. Okay, so basically, I have to make a model that is that so that it can make a prediction like who will pass the exam or who will not pass the exam. Okay, so I'm having some past data already. Okay, like someone is there who had who came into the class for, suppose there were total, suppose 30 classes, right? So out of 30 classes, everyone attended some number of classes. Like he had attended 28, someone had attended 22, someone had attended 20, someone had attended 23, someone had attended 21, someone had attended 15. Okay, so everyone attended some number of classes. Okay, and there were total, suppose 10 assignments. Out of 10 assignment, everyone had finished some number of assignment. Okay, so out of 10, suppose he did, suppose 8 assignments, he did, suppose 9 assignments, he did, suppose 3 assignments, he did, suppose 5 assignments, he did, suppose 6 assignments, he did, suppose it is like he just did, suppose 7 assignments, right? And then result is what? He just passed the exam, he also passed the exam, he fails the exam, he fails the exam, he also fails the exam, he also passed the exam. Okay, now in future, suppose there is a guy, he just attended, suppose 19 classes, did almost 6 assignment. So will he pass or will he not pass? Okay, 19.6, and will he pass or will he not pass? Okay, that is a query. Correct. So how it can be done? Correct. So this can be, in decision tree classifier, the decision will be made with the help of tree shape divisions. Okay, so first of all, decision tree classifier will divide the things on the basis of some criteria. Okay, criteria means, suppose it can take any criteria. Okay, like it can take attendance or assignment. Okay, suppose it is taking attendance part. Okay, so it is considering attendance. Okay, greater than, okay, greater than suppose 22. Okay, so if attendance greater than 22 is considered, okay, so here it is yes, here it is no. Correct. So in this case, attendance greater than 22 means what? The first sample will come over here 28, 28, 8 and pass. Okay. Second sample will not come, third sample will not come, fourth sample will come 23, 5 and fail. Okay. And then other will not come, right? And over here what will come? Over here it will come like first will not come, second will come, sorry, 22, 9 pass. Okay. 23 fail. Okay. 23 will not come, 21, 6 fail. Okay. And over here 15, 7 pass. Okay. So it is how things will be done. After this, what will happen? After this, your model or your algorithm will figure out the error value, will evaluate the error or will evaluate the accuracy level. Okay. So how it will evaluate error or how it will evaluate accuracy level, that we have to discuss. Okay. So here in case of decision tree classifier, the thing that is calculated is known as what? Gini index. Okay. So how to calculate Gini index? Okay. So let us consider the case 1. In the case 1, okay, what is the probability of pass? There are two categories, right? So what is the probability of pass over here? The probability of pass is 1 upon, okay, 2. Okay. And what is the probability of fail? Probability of fail is 1 upon 2. Correct. So it is 1 upon 2, 1 upon 2. Both the probability has been calculated. Thereafter, what will happen? Thereafter, Gini index will be calculated. Gini index, for calculating the Gini index, any of these criteria can be considered. Okay, so it can be considered like this. Just a minute. Okay, it can be considered like this. Okay, it will use like this. Okay, probability of pass multiplied by 1 minus probability of pass. Just a minute. Okay. Okay. So what is it? It will be like 1 upon 2 multiplied by 1 minus 1 upon 2, that is 1 upon 2. That is equal to 1 upon 2, 1 upon 2 multiplied by 1 upon 2. What will be the output? If you are multiplying 0 0.5, 0 0.25, isn't it? So basically what happened, we are getting 0 0.25. Okay, this 0 0.25 is showing what? This 0 0.25 is showing that this categorical division is not a pure subset. Pure subset means what? A subset where all the features belongs to just one category. Okay, and when it will be possible? It will be possible only if, okay, it will be possible only if the Gini index is 0. For example, consider a case, a particular subset where the pass, all the values are passed. Okay, if all the values are passed, then what is the probability of pass? 2 upon 2, that is 1. Okay, or whatever the probability will always be 1. Okay, 1 multiplied by 1 minus 1. Okay, that will be equal to what? 0. Right, that means Gini index is what? 0. So Gini index 0 represents what? Pure subset. Correct. If Gini index is not 0, okay, that means it is not a pure subset. Okay, and if it is not a pure subset, that means it can't be used for making the making the predictions or making the decisions, right? So if it is not a pure subset, in that case what will happen? In that case, your criteria of dividing the things will change. Okay, over here the changes will happen. Okay, over here the changes will happen. Okay, for example, initially the attendance we considered is 22. Okay, now it can consider something else. Okay, then again gene index will be calculated, then again something else will be considered. Okay, for example, let me remove this part completely. And let me write this thing properly over here. Okay, so let us consider a case, okay, where, okay, here it is your complete data. Okay, this data will start dividing itself. Okay, so first I am considering the attendance, okay, greater than 20. Okay, so here it is greater than 20. Okay, so that means what? 28, 8, pass, 22, everyone it is greater than 20. I should use something else. Okay, let me do it. Greater than 23, I should use. Okay, greater than 23, just suppose. Actually, so many things have been there. It will be little. Okay, just a minute. Attendance greater than equal to 22. Okay, 22, 9, pass, right? And what? 23, 5, fail. Okay, and here it will be what? Okay, here it will be what? It will be like 28, 20, 3 fail. Okay, 23, 5 fail, and then 15, 7 pass. Okay, so you can see in both the case it is not a pure subset, so obviously in both the case you will not get gene index 0 according to the formula. Okay, probability of pass is what? 2 upon 3. Okay, 2 upon 3 multiplied by 1 minus 2 upon 3. Okay, so 1 minus 2 upon 3 will be what? 1 upon 3. Okay, so obviously this is not 0. If it is not 0, that means it is not a pure subset. Okay, so again division will happen. Okay, from this point of time again division will happen. So you can see how tree shapes are generating. Okay, and it will keep dividing itself until unless you reach it at a point where pure subset is there. So now division can be there on some other condition. Okay, like it can be there on some other condition, but the target remains same, to figure out Gini index 0. Okay, so now it can be like assignment greater than 5. Okay, so if assignment greater than 5, 28, 8 pass, 22, 9 pass. Okay, and over 23, 5 fail. Okay, so you can calculate the Gini index in both the case, it will be 0. Correct. So if it is not 0, then your algorithm will keep tuning this thing. Okay, it will keep tuning this parameter or this parameter. It will keep tuning the parameter. Okay, and it will keep tuning the parameter to make it possible that you should receive a minimum or 0 index. Over here, it will be what? Assignment. Okay, greater than is equal to 7. Okay, in that case, 15, 7 pass, and over here 20, 3 fail, 23, 5 fail. Okay, now the question was 19, 6, 19 assignment, 19 attendance. So 19 means what? It should come in this case. Okay, this is a 19. Okay, because it is yes, it is no. Now 19 and then 6. 6 means what? 6 greater than equal to 7. No, it is smaller than equal to 7, right? So it will come over here. Okay. That means this person will fail the exam. Okay. Your model can easily predict that this person will fail the exam because he is basically dropping himself in this category. Correct. So what exactly happens? The process is like this. First of all, there is a division criteria, there is a condition with on which division can be possible, that criteria, that condition is defined. After that condition defined, the division starts. After the division, gene index calculated. After the gene index, again algorithm will tune this particular parameter. Okay, it will keep tuning this parameter to reach to either zero gene index or minimum gene index. Okay, so whatever the minimum is there, if it is a minimum, it is not zero, it just reaches a minimum value, then again it will divide it. Okay, and then again it will divide it, then again it will divide it. It will keep dividing the things until unless it reaches to a zero zero index. Okay, so how basically a algorithm focuses or trying to reach zero gene index? Two ways. First, by tuning this parameter, and second, by increasing the depth. First, by tuning these parameter at each stage, by tuning these parameter at each stage, again and again it will tune these parameter at each stage, or second, by increasing the depth. Okay, so whatever suits it, according to that algorithm, keep trying and keep developing your depth or tune the parameter to reach a condition where it can make the predictions for the future values. Okay, so this is what decision tree classifier. Right, this is what decision tree classifier. Right, now how to use it? Correct. So we had seen two different algorithms, KNN algorithm and decision tree classifier. So let's use it to understand how things works in actual world, right? So to use it, like in last class, I will use same collab. Okay, I'll click over file first, new notebook. Okay, so it is my new notebook, right? What notebook? Just a minute. Just wait a minute. Okay, so I'll give it a name D2. Okay, so how can we program for making a predictions? We need some data sets, right? So I told you how can you pick the data set in last class. Okay, today I will use some toy data set. Toy data set means what? The data set that is already there in the library. Which library? The scikit-learn library. Okay, so let me use it from sklearn dot data sets import load underscore iris. Let me check if it is working or not. So scikit-learn is a basically is a library that is used in machine learning programs. Okay, so that library is having some data set, inbuilt data set, just for the practice, so that one can practice and can learn like how a machine learning models can be developed, isn't it? So iris is equal to load iris. So this is how you can import it. Okay, so I have imported one of the set that is known as iris dataset. Iris dataset is basically a flower dataset. Okay, so it is our data set. So it may be looking like a little, little complicated, right? Don't worry about it. It is very easy data set actually. It's a flower data set that is used to make a predictions of type of flower. Okay. So basically, iris flower is having three different categories. It is like setosa, versicolor, and virginica, isn't it? So it is the data set about that particular thing. Okay. Now the data is looking little, glitchy. So what we can do, we can just use over here iris.keys. Okay. Why I'm using keys? Because data is in a format of dictionary. Okay, so dictionary is having two things called keys and values. Okay, so when I pick the keys, it is showing that it is having these many keys. Okay, now we will see what are there in these keys. If I consider the first key, okay, so I am having what? Iris data. So this first key is containing actually the data. Okay, so this data is having what? This data is having total four columns. Okay, it is having how many columns? Four columns are there. A minute. Okay, I guess I can annotate over here. Yeah. How can I erase? Okay, I got it. Okay. So there are four columns. Oh my God. What happened? Okay. You can see these four columns are basically what? Basically your four features. It is all of a sudden to just, okay, it is not working actually. I don't know why. Okay, so there are four columns, column so one, column two, column three, and column four. These four columns are representing four features. What are those four features that you can easily get by picking up the feature names? Okay, so iris, feature names. So there are four features, right? Sepal length, sepal width, petal length, and petal width. Right. That means this flower, like any other flower, this flower is also having sepal, petal, sepal, and petals. Okay. So basically, here the features containing what? Sepal length, sepal width, petal length, and petal width part. Okay, so that means the category of flower is dependent upon these four features. Okay, so four features has been calculated, has been given to you, and based upon the four features you have to develop a model that can make the predictions for the future incoming flowers. Okay, so these are the four features. So data we checked, feature names also we checked. Let us check the target and target names. Right, just a minute. Iris, target. So these are the targets. Okay, so targets are represented in numerical 0, 1, and 2. Why? Because algorithm can only understand and can only interpret the numerical values. Any algorithm can't understand if you're giving it a name like any name in a kind of a string or something, right? So these are what target. Okay, so we had seen what is there in features name, we had seen what is there in data. Data is having what? Data is having the four columns. These four columns are representing for sepal and sepal width, petal length, and petal width for any single flower. This is for one single flower, this is for another type of flower, this is for another type of flower, this is for another type of flower. So there are so many flowers are there. So for different flowers we are having different feature names. Okay, sepal length, sepal width, petal length, and petal width, and then target is there, and then we are having what? Target names, right? So let's see the target names. Okay, target names are three. Okay, setosa, versicolor, and virginica. That means there are three types of flower. Okay, if you consider iris flowers, so iris flowers are having three different varieties. Okay, so these three varieties are setosa, versicolor, and virginica. So these three varieties are dependent upon what? These three varieties are dependent upon the four features. Those are sepal length, sepal width, petal length, and petal width. Right. Next, what we have to do, we have to make a model so that in future whenever a new flower will come into the picture, that flower can be predicted either as setosa, versicolor, or virginica. So how can we develop a model? To develop a model, the very first thing we need is features and labels, right? So what we will do, first of all, we need what? We need a feature and we need a label. So first of all, feature, and second thing we need is what? Labels. Correct. So where are our features present? Features are present in iris. What was that? Feature data, right? This is our feature. Okay. And where is our labels present? Labels are present in iris. Target names or target? I guess target, right? I'm not sure. Let me check again. Yeah, in the target. Labels are present in target. That is 0, 1, and 2. 0 is representing your which flower? Setosa. 1 is representing versicolor and 2 is representing virginica. Okay. So this is what we are having. Correct. Now we have to train our model, right? So to train our model, we need algorithm. So how can we use algorithm? We can import it like this from sklearn dot, okay, neighbors, import k neighbors classifier. Okay, so these are there in sklearn, sklearn documentation. Okay, and then define a object for it. K model is equal to k neighbors classifier, and then k model dot fit x comma y. So these only this three line is required for any kind of model to get trained. Okay, if you're using scikit-learn, only these three lines are required, right? So just train it. So model get trained with number of neighbors 5. Correct. Now if number of neighbors are 5, that means at a single point of time, okay, if you want to make any kind of prediction, it will consider 5 nearest neighbor to make the predictions. What I mean, suppose I am having a flower. Okay, my flower dimensions are like 2.1 sepal length, 3.2 sepal width, 4.3 petal length, and 4.4 petal width. Okay, these are my flowers dimension. Okay, if these are my flowers dimension and I have to make a prediction, what are these? Okay, so my model, which model? Model is K model. This K model will use dot predict. Okay, what it will do? It will use, right? It will use these 4 features, okay, to make the predictions. Okay, it will use these 4 features to make the prediction, but at a single point of time, after calculating the distance from all the given samples. Like in the very sample is there in x, so x is containing 150 sample. So what it will do, K model will calculate the distance of 150 samples. Okay, it will just calculate the Euclidean distance from all those 150 samples, and then it will consider the 5 nearest one. So whatever the 5 nearest ones are there, based upon that it will make the predictions. So let's see what prediction it is going to make. 2.1 comma 3.2 comma 4.3 comma 4.4. Okay, so the prediction that it is making is 2. Okay, that means total number, that means what? 2 is what? Virginica. Okay, that means it made a prediction for virginica. Okay, now I am having one more flower. Okay, so their sepal length is what? Suppose 2 point, the sepal length is suppose 5, 1.1 comma 2.1 comma 1.5 comma 2.4. Okay, it is what? 0, that is setosa. Okay, so what it means? It means the first type of flower is virginica and second type of flower is what? Setosa. Correct, because the prediction is what? 0. Okay, I hope you got it. So it is doing what? It is calculating a distance and considering the 5 nearest one. Correct. Now the thing is, here whatever the predictions it is making, okay, suppose I am just giving this particular model to someone. Okay, I'm saying that my model is making a prediction, and if someone will ask me that what is your accuracy, what is the accuracy of your model, then what I can do? Okay, so to get the accuracy of my model, I have to make the predictions over all that given data. Okay, because these are unknown value. On the unknown value, you can't calculate the accuracy, right? On the known value, you can calculate accuracy only, right? So K model dot predict, okay, x. Make the predictions over complete data, that is x. Okay, your predictions will come out. Okay, now compare your prediction with what? With the actual level, that is y. So when you compare your prediction with the actual level with the y, you will get what? True or false. Okay, now if you're getting true or false, in last class already I told you if you are having true or false and you have to calculate the number of true, what you can do? You can just put over your dot sum. So what are you getting? 145. Okay, that means it happens out of total instance. What is a total instance? Total instance is length of x. So total instance is 150. Out of total instance 150, 145 times the predictions was correct. That means 145 times it was true. True when these twos are compared. What are compared? Y. Y is what? Actual level and the predicted level of x. So what is the accuracy? Accuracy level is 96%. So I will say that my accuracy is 96%. Okay, or my model is predicting with an accuracy of 96%. Okay, then the person will say, okay, that's great that your model is predicting with an accuracy of 96%, but again, it is predicting 96% accuracy is there on the training data. Okay, means the data that we had used for the training, that means I had used the data x for the training, and on the x only I am getting 96% accuracy. Okay, how it will behave on unknown data? Like, will it behave with that much accuracy on unknown data? So what I will do, I will just generate unknown data from the existing data itself. And that is known as what? Train, test, split. That means I will split my data into two parts. That is X training part and the testing part. How I can do? I can do by using inbuilt library from sklearn dot model selection import. Okay, so that's it. It will divide your x into two parts. What are those two parts? It will divide your x into two parts. Those two parts are known as x train and x test. And it will divide your y into two parts that are known as y train and y test. Okay, x train, x test, y train, y test. Okay, so x has been divided into two parts and y has already been divided into two parts. That is y train and y test. Okay, now if you execute it, right, so it is what your train and test split. That means now your training will be done on one of those parts that I told you earlier, x train and y train, that I had explained in the theoretical explanation. So training is done, prediction in all those things are there, right? Now y train, now you will compare over here y train double equals k model dot predict x train and divided by what? X train. So this is what? This is your training accuracy. Like, it is what? It is your training accuracy. Okay, training accuracy 97%. Okay, so let's discuss about the testing accuracy. Okay, so testing accuracy will be what? The testing accuracy will be done over the testing data. And where is testing data? Testing data is x test. That means training has been made on x train. You can see training has been made on x train and y train. Okay, and accuracy is calculated on the same data set on which training is made. That's why it is called training accuracy. Training has been made on x train, but accuracy is getting calculated over x test on which there is no training made. That's why it is known as testing accuracy. Better? So testing accuracy is almost same than the training accuracy. So whenever we are having this kind of condition, we can say that my model is working very nice. Okay, it is working perfectly. That's why we are getting high accuracy in both case. Correct? Next is uh, okay. Next is what? Once this is done, okay. Next we should know the parameter tuning. What is parameter tuning exactly? Parameter tuning means the value of k. Okay. So in any algorithm, there is a parameter that you can tune. Okay. So how can you decide that the value of k should be 5? It should be 3, or it should be 2, or it should be 1. Okay. We can decide it if we know the accuracy level at other parameters as well. That means if I am knowing the accuracy level at number of neighbors 3, if I am knowing the accuracy level at number of neighbors 2, then I can compare that accuracy with the number of neighbors at 5, isn't it? So to tune the parameter, what we will do, we will use for I in range, okay, 1 to 15 or 1 to 12, okay, k KMTR for the training things. Okay, what I should do? Just a minute. K neighbors classifier. Okay, thereafter KM, or you can use this thing as, just a minute. Okay, I can use K model only. K model equal to this much. Okay, thereafter K model is equal to, sorry, I guess I did a mistake. Just a minute. N neighbors is equal to what? N neighbors equal to I. Okay. So for I in range 1 to 12, I am changing the number of neighbors to I. That means first of all, number of neighbors will be 1, then 2, then 3, then 4, then 5. Right? Thereafter K model dot fit. What I will do, I will just fit the data, that is X train, Y train. Okay. And then I will calculate the accuracy. For calculating the accuracy, there is one shortcut way is also there. That means the way you have calculated the accuracy over here, you can calculate like this also. K model dot score X train, Y train. Okay. So this will also give you the score. You can see you're getting the same value. Okay, it means same, correct? So same thing we will do. K model dot score X train, Y train, correct? And then training accuracy is equal to null. Okay, and then tr underscore acc dot append. Then so what it will do, it will train your model first and then calculate the accuracy, then again train, then again calculate the accuracy, and this is how all the accuracy will be appended over here, right? So thereafter, once it is appended, what we will do, import matplotlib.pyplot hplt plt dot plot. Okay, on the y-axis put range 1 to 12, and on the y-axis put tr underscore acc and then plt dot show. Okay, so what are we getting? We are getting a situation where, just a minute. Oh, excuse me. Okay, so I'm sorry, I tried to mute but I can't. Anyway, so we are getting a situation where we are getting an accuracy of 100% when number of neighbor is 1. Okay, and accuracy is changing like this. Okay, so that means shall we choose number of neighbors equal to 1 in this case also? Like if we are going to do over here, if I can define over here number of neighbors equal to 1, then I will get a maximum accuracy. Shall we go through it? No. What we will do, we will also try to figure out how my model is behaving for testing data, correct? So what I will, something over here, testing accuracy is equal to null, right? and then we will calculate the testing accuracy over a K model dot score X test comma Y test. Okay, it will be a score for testing data, and then TS underscore ACC dot append. Okay, so it will append your testing accuracy. Okay, and then execute it. So along with training accuracy, just plot plt dot plot range 1 to 12 comma ts underscore acc. Okay, so we are getting this figure, right? So it shows that if number of neighbor is 5, then I'm getting the best possible condition, because if number of neighbor is 1, then obviously I'm getting a very high accuracy, but I'm getting that high accuracy over the training data. Okay, but on the testing data the accuracy is not that good, so that can be overfit model. Okay, so that's why whenever you are evaluating your model, after preparing your model, and whenever you are going to evaluate your model using any algorithm, right, you should evaluate your model on the training as well as the testing data. Training data is that data on which training is made. That means that data that is exposed to the algorithm, the data that model is already knowing about it. Okay, so that is called your training data. So on the training data, if accuracy is high, that doesn't mean that on the testing data also it is going to be high. Okay, that depends. Okay, so that's why first of all you should train your model on training data, and thereafter you should check your model performance on the testing data as well. If it is working good on testing data, then you can use it for your kind of for the deployment purpose. Okay, and otherwise you can tune your parameter to find out the condition where training and testing data both are, sorry, training and testing accuracy both are behaving good. Okay, just figure out that particular condition where training and testing both the things are working good or behaving in a behaving synchronized in a synchronized way. Correct, so it is how we can do the things. Okay, so let's consider one. Okay, so this is an example of what these were the example of iris data. So let us before I will take your query, let me consider one more example. So what example I can take? I will use that sklearn try data set only. Just a minute. So let take handwritten digits. Okay, let me take handwritten digits. So from sklearn dot what is this? Data sets import. I just missed the name of that particular data set. Just a minute. And return digits data set sklearn. I guess load digits. I reminded. I guess it's load. Let's go digits. I'm not sure. So digits. Okay, so it is our digits, right? So let us consider the digits part. Okay, so it is also showing some data like this, right? So it is not looking good, right? So what I will do, I will just use dot keys over here. Okay, so these are the keys. In these keys, the first thing is representing the data, isn't it? That means digits. Okay, this is our data. Okay, these are our data. Okay, and these are our, the next is our target. So target is representing from 0 to 9. That means these digits are showing a target of 0 to 9. Okay, so data is representing features, target is representing label, that we already knowing. Okay, there are target names. Okay, these are the target names, that is 0 to 9. Okay, and thereafter you are having what? Images and then description. Description is not important. What is images exactly? If you look into the images data, it will be similar to your data. That means this data. Okay, there is a very little difference that I will tell you. Digits, images. So it is almost same. Okay, it is almost same, right? But there is a very small difference between these two. Okay, the difference is with the shape. Okay, so for example, if you will check the shape of both of them. Okay, for example, print, it is digits, right? Digits, data dot shape, and print digits, images dot shape. So what are you getting? The first one is having a shape of 1797. That is total 1797 samples are there, representing a digit from 0 to 9. Okay, with 64 features. And second is also 1797 features, but 8 cross 8. That means this 64 has been arranged in images. In the images, it has been arranged in 8 cross 8. Why it has been arranged in 8 cross 8? Because you know that any image is basically can be represented in 2 dimension. That means you know at least 2 dimension is required to represent any image. Okay, what I mean, suppose you have to represent an image, obviously the image will be, just a minute, the image will be what will be shown like this. Okay, it will have what, it will have some 8 crosses, 100 cross 100, 200 cross 200, 700 cross 700. Okay, 500 cross 500, something can be there. Okay, but there will be always two-dimensional values will be there. So it is what, it is 8 cross 8. 8 cross 8 means what, each particular image has been converted into 8 cross 8 format. Each image has been converted into 8 cross 8 format, and that's why it is what image. That means that can be directly converted on the what, that can be directly plotted over a image plot. Okay, this thing can be directly plotted over image plot. How? Let me show you. Just pick any particular sample. Okay, what sample? Digits. Okay, sample number, suppose the total 1700 samples are there, let's pick sample number 200. Okay, so this is one of the sample, sorry, did a mistake. Sample number 200. Okay, so this sample number 200 is having what, 8 cross 8. Okay, 8 in horizontal, 8 in vertical. Okay, so these 8 cross 8 is representing an image. Image, the pixels values. Okay, like if someone asks you that he needs an image of 100 cross 100, then what he needs an image in which there should be 100 horizontal pixels and there should be 100 vertical pixels, isn't it? So here, how many horizontal pixels are there? Total 8 horizontal pixels are there. And how many vertical pixels are there? Total 8 vertical pixels are there. Correct? So how it can be plotted over an image plot, how it can be used to plot an image? Okay, so it's very easy to plot an image actually. What you need to do, you need to import a library called matplotlib, right? Import matplotlib as plt, then plt dot imso. Okay, and what I can give over here, you can just give over here this thing. So it is giving you certain image. Okay, so it may be 4 or 1 some image that you are getting over here. Now what you can do, you want to see the label of it. So the label is stored where? The label is stored in, is basically stored in target, right? So let me do one thing. I will just define this particular target, the data into x, okay, and target into y, right? So let me check what is it. Print y 200. So it is representing 1, correct? Now I have to train my model. How can I train my model? Okay, I have to train my model. Then how can I train my model? To train my model, I need an algorithm. So where is my algorithm? I have to import the algorithm, isn't it? So it is like SK. I already told you about the KNN. So let's do it for the KNN. But before that, I have to divide it into two parts: training and testing. So from sklearn dot model selection import train test split. Okay, and thereafter xtrain xtest ytrain ytest is equal to better. So it is divided. Now what you can do, you can, once it is divided, you can train your model. How can you train your model? You can train your model with the algorithm. So you need to import the algorithm. Just import the algorithm from sklearn dot which algorithm should I use? Okay, let me use first KNN only. Thereafter I'll use decision tree classifier, right? Neighbors import k neighbors classifier. Okay, KMS is equal to k neighbors classifier, and thereafter as I told you, KMS dot fit. That is, fit is a function to train your model. Okay, xtrain comma ytrain. Okay, so it is how your model will be trained. So once it is trained, what you can do, you can calculate the accuracy for testing and training both. So training accuracy first, okay, and then testing accuracy. So what is training accuracy? Training accuracy is like this: print kms dot score xtrain comma ytrain. And what is the testing accuracy? Correct? Better? So training and testing accuracy both are around 98-99%. That means it's better. The model is basically behaving well, right? Now we have calculated training accuracy, testing accuracy. Now the predictions. Okay, so where should I make the predictions? I'll make the predictions over xtest. Okay, I can make the predictions over xtest. So let me pick xtest. Okay, it is xtest. In the xtest there are so many values. Let me pick a value. Suppose I'm just picking a value, suppose at position 40. Okay, so what is it? How can I make the prediction? I can make the prediction by using kms dot predict. Because why I'm making a prediction over xtest? Because on xtrain already model has been trained, kms has been trained on xtrain, right? So now if I predict it, what am I getting? I am getting the error. Okay, it is saying it required 2 dimension. Whenever you get this kind of error, expected 2D array, okay, what it means? It means that training has been made on 2-dimension data, but since you are passing a single sample, so single sample is basically present in single dimension, that's why it can't make the prediction, because the model can only make the predictions over 2-dimension data, because training has been made on 2 dimension. Obviously training will be on 2 dimension, because on the training we are using, during the training we are using multiple sample, and if you are using multiple sample together, it will be always 2 dimension. Indeed, multiple sample can't be in single dimension, but a single dimension can be in, a single sample can be in single dimension. Okay, so where what are we using? We are using single sample. That's why it is in single dimension. So just put this thing in one more bracket, make the prediction. So predicted value is showing 5. That means it is representing a 5. Okay. Let us see what is actual level. Okay. Actual level is also 5. Let us plot the image also. Plt dot im show, that is image show. Okay. What I have to show? I have to show X test this thing. Okay. Obviously it is in single dimension, image will not be visible or image will not be shown. So reshape it. I told you the reshaping part into 8 cross 8 and then show it. Okay. So this is the image called 5. So we had discovered how we can train. For training, first pick the data, divide the data into two part x and y, then divide x and y into two part x train, x test, y train, y test, then import your algorithm, then train your model, then calculate the accuracy to validate the model, and then make the predictions, and everything will now work fine. Okay, and thereafter image and all those things you can print, right? So it is a simple process, right? Next, if we have to use some other algorithm, that also we can use, right? It is simple to the similar to the algorithm that we used over here. For example, you have to use decision tree classifier, then what you can do? Nothing to, it will be almost similar. Okay. Decision tree. I'm sorry, a little. Okay. So for decision tree classifier, we need again algorithm to import. So directly you can visit the scikit-learn official documentation. You can see over there that the different different commands to import the different algorithms. Okay. So from sklearn dot tree import decision tree classifier, d model is equal to decision tree classifier, correct, and then d model dot fit what x train comma y train. So we trained our model, and once we trained our model, there are so many things that we can see over here that I will explain what is it, right? As of now, thereafter we'll calculate the accuracy. What accuracy? The same training and testing accuracy. So what I will do, I'll just copy this thing, I will paste it over here. Okay, and over here I will pass what d model. Okay, so over here the accuracy over training data is 100%, but testing data 84%. So it is a situation that we have to avoid. Okay, it is a situation that we have to avoid, because this kind of situation is known as overfit model, where the training on the training data model is performing exceptionally well. Okay, on the training data model is performing exceptionally well, but on testing data the model just crashed. Okay, so the question is why it is happening. Okay, then only we can make it correct, right? So basically the reason behind it, like whenever we are using any algorithm, okay, in some cases your model gets overtrained. Okay, and why it is getting overtrained? Okay, so I will just tell you this part. Just wait a minute, just give me 1 minute, right? Okay, so why your model is getting overtrained? Your model is getting overtrained because, okay, because it is running for 0 Gini index. Okay, that means it keep dividing the things. For the training data, it keeps dividing the thing until unless it gets a 0 Gini index. Okay, because it is a decision tree classifier, and 0 Gini index means what? Zero error. Okay, so at the end, what happened for training data, it generates the division for each sample. It generates a category. Even there is a bucket that is having just one sample, then also it is accepting it. Okay, just a minute, I will show you. First of all, if we can visualize this particular tree, it will be easier for us, isn't it? So I will just let you visualize this tree. Basically, I have to find out a library that can be used. Just give me 1 minute. Library I am looking for through which you can visualize the tree. I will tell you just a minute. 1 minute. It's a very famous library actually. Yeah, I got it. So using that library, what you can do exactly? You can visualize your tree. And if you can visualize your tree, you can do a lot of things. Okay, you can decide what to go and what not to do. Okay, so from sklearn dot tree import export graph is right, and then from ipython dot display import image import py dot plus. Okay, so these are three libraries that we need. Okay, thereafter we have to use it. So how can we use it? We can use it like this: dot underscore data is equal to, first this will be used, export graph is, okay, and pass the model into it, d model. Okay, and thereafter what we can do next, graph equal to, this will be used. Next, py dot plus dot graph form dot data and then image graph dot create underscore image. Okay, so it will give you the graphical shape. Graphical means what? Not graphical, it will give you the tree shape. Okay, tree of the division. You can see how the tree has been created. Okay, it is very small, right? So we'll just click it to make it bigger. I just, okay, you can see over here. Okay, so these are the tree. Okay, so this tree started its division over here. Okay, so you can see total number of samples it is having 1347 in training data, right? Now x of 36 means what? That means there are total 64 features. Okay, so it divided itself on the basis of 36th feature. Why? Because at the when it is dividing itself with the 36th feature, it is getting a minimum possible gene index. That you can see the gene index in this case is 0.538. Okay, and these are the value. Okay, that means there are 134 0, there is no 1, there is 3 2, okay, there is 1 4, there is 5 5, there is 19 6, 4 7s, 0 8, 2 49. Okay, 0 1 2 3 4 5 6 7 8 9, yeah, 49. Okay, so this is how the things have been divided, right? And it will keep dividing the things and increasing the depth. You can see over here it reaches up to a point where at least where it is having just one sample, but gene index is 0. So that's why it gets overfitted. Okay, that means for each particular sample for training data, okay, the tree has adjusted itself. Okay, the tree has adjusted itself for each and every sample. That's why on training data accuracy is 100%, but on testing data it is not that much good. Okay, because the same tree can't help out over here. Okay, so in this case we use what? We use certain stopping criteria. There are so many stopping criteria that you can see over here. For example, there is a stopping criteria maximum depth. Okay, maximum depth means what? You can just regulate the depth. You will say that no, maximum depth can be 3, maximum depth can be 7. Okay, so in that case what are you doing? You are regulating the depth, and this regulation, by regulating the depth you can regulate a model so that the model will not go beyond a particular stage. So you can see that the training accuracy decreases to 88% and testing also decreases, but you can see the graph will also gets up to 7. Okay, so we can make it something else also. We can make it like what again, 10. Let us make it 10 and just check it out how things are behaving. Okay, so it is not getting changed too much, right? So there are certain things also like maximum features, maximum leaf node. Maximum leaf node is what, and what is maximum feature? Okay, that means what, each node can contain how many maximum feature, that is maximum feature. Okay, these are the nodes. Okay, these are the after division. For example, if I will make it less, because I'm making it this 3. Okay, so these are what, these are the nodes. Okay, and what are leaf nodes? These last nodes are the leaf nodes. Okay, the last nodes are the leaf nodes. Okay, so maximum feature means what, you can regulate like how many features can be there in each node. Okay, maximum leaf node means what, you can regulate like how many leaf node at the end you are expecting. Okay, as of now how many leaf nodes are there? 1 2 3 4 5 6 7 8 leaf nodes are there. Okay, you can regulate it, right? So you can just give over here. Okay, I am expecting now maximum 15 leaf node. So accuracy, yeah, obviously the accuracy is not good, but training and tracing accuracy is quite close. This is far more better condition than the earlier one. Okay, that means now you can say that okay, my model is will behave in a range of accuracy 76 to 78%. But if your testing accuracy is 81%, consider a case where testing accuracy is 81% and training accuracy is 100%, then what window you will give? You can't say anything, you can't give any figure. Okay, that okay, my model will behave in 80 to 100%, so you can't say like that. But here you can say that okay, my model will behave around 76 to 78% accuracy, right? So your graphical representation will be like this. So it is how we can regulate it, right? You can tune it continuously, okay, with different things. Like you can make it now 20 as well, just to check how it is behaving now. Okay, much better, correct? Then we are having maximum impurity decrease, like how many impurity that you want at maximum should it decrease. By default it is going to 0. By default it is going to 0. You can also set it, like you can set it no, if it is up to 0 point, uh, not 0, if it is up to 0.2, then also it can be accepted. Okay, the multiples also you can give, okay, like it is like this. Okay, say no, up to 0.2 I can accept. Okay, in that case I can use the majority. Majority means what? Suppose in a particular block there is one of the item that is having a 90% strength. Okay, obviously if Gini index is not 0, if Gini index is not 0, obviously it is not a pure subset. But if it is not a pure subset, then that doesn't mean that we can't use it for the prediction. There must be some number which is in majority. There must be some category which is in majority. Suppose there is a category which is containing 90% of the complete strength in a particular block. So we can use that 90% strength for making the predictions, isn't it? So that's what is it means. Okay, that means my model will not run behind 0 Gini index. Okay, so your accuracy also decreases actually. So it is not helping out over here. Something else also we can use. Depends upon like sample to sample. Minimum sample leaf, like how many samples you want in a leaf at a leaf node. So minimum sample is what? Suppose I'm giving 10. Not so much affected. So this is what you can do. Okay, you can keep changing the parameters in any case, and to make the predictions like how it is going to behave. Okay, how it is going to show the output, right? Apart from this, okay, I will give you some additional things to work upon. Okay, I will share this code with you. Okay, before sharing this code, let me share with you some data sets. Okay, that you can try using KNN as well as decision tree classifier. There is a data called breast cancer tumor data. So from sklearn dot data sets import just a minute. The exact name I just missed. Load breast cancer rate. So this data is containing features. So so this data is containing what? This data is containing the features. Okay, the data, target names, description, and all. So you know what to do with it. Okay, data is containing data. Target is containing the target, like types of tumor. There are two types of tumor basically present over here. Okay, you can see. Okay, there are two types of tumor. Okay, and feature names are containing what? Feature names are containing the feature. There are so many features actually. Okay, so based upon the features like mean radius of a tumor, mean texture, mean parameter, mean area, mean smoothness, right? A tumor can be classified into a malignant or a benign. Okay, so you have to develop a model that can make the predictions about a tumor, that a tumor is going to be is basically a malignant tumor or a benign tumor based upon its feature. Okay, so these are the different features that we can use for train your model. You know about KNN, you can go with KNN. You know about decision tree classifier, you can go with decision tree classifier, and then you can compare both of them. Okay, if you're knowing some other algorithm, just try those algorithms as well, and then compare those algorithms on the basis of accuracy or error, like how these algorithms are performing. This is your feature and this is your label. Okay, so just go with it and have some doubts. If you're feeling any difficulty, if you face any kind of a problem while doing it, okay, note down your doubts. Tomorrow again we will meet, right? And thereafter we will discuss the doubts on this particular problem. Okay, let me share this thing with you. The complete file I am sharing with you, that you can just click over the link, okay, and you can get the file. Okay, so this is a file, everything is there. This complete file you can get, okay, and then you can practice. Yeah, please, anyone wants to ask something, please.
Any queries from participants? Okay, Vipul, I think everyone has cleared all doubts. Okay,
Right.
you shared all the things, no? Okay.
Yeah, I have shared on the chat. You can just click over this link. You'll get all this program, okay? And just go through
Right.
it. And with some other data set, if you want to practice, you can practice. And tomorrow, if any doubts, you will discover. If you generate any doubt or any kind of question, note down, and
Right.
tomorrow I will solve that part, right?
Right. Please also one query was there.
Mhm.
Share collab link. Yeah.
Yeah, this collab
So,
link I had shared over here
okay.
in
Okay. No problem.
in the
Means
chat.
this is enough now. Okay.
Yeah,
Ah,
yeah, this is the collab link.
right. Right. Okay. 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 Thank you, Vipul. Then.
Okay, that's
Okay. Okay. We end
Hello,
this
sir.
session. Yeah. Yeah, ma'am. Please.
I'm Sakre Madam from A.G. Patel Engineering College, Sholapur.
Right.
hi, madam.
Actually, I wanted to know, like, how much is the time used to execute using MATLAB and that of Python? Can we compare the time execution required for both of these? Like, does it take longer in MATLAB or it is longer in Python?
No, in Python it will take a less amount of time because Python is having a quite you can say the dedicated library that has been created, as well as uh, basically it depends upon the cases as well. Okay, I can't say like that also that okay Python will always take less amount of time. It depends
Mm-hmm.
upon case to case. Correct.
Okay, sir.
Like suppose there is some very huge image problems you are solving. Okay, like a image problem with a kind of that consists of that is containing so much memory, using so much memory in the backend. Okay, so in that case MATLAB may help us more because MATLAB is basically designed or defined for you to
Yes,
use
sir.
images more properly, right? So in
Yes.
that case MATLAB can help us more, right? So it depends upon case to case. Okay, but
Okay.
without applying or without using, it can't be defined. There's no way it is defined that okay, MATLAB will take less time or this one. That depends on case to case.
Okay, so it depends upon like because
Right,
I am
right,
a
right.
researcher now. Actually, I am
Uh-huh.
working with medical images. Like I am taking the images of the fruits, and
Uh-huh.
from the texture, I want to predict the chemical values inside. So this is what my work is actually,
Uh-huh.
and in that I'm using MATLAB as my tool.
Uh-huh.
But if you want to make it like a user friendly, then
Uh-huh.
probably Python would be more easier for the user end. Is it not? Because
Correct,
it's available
correct.
in the mobiles and all also they can do it.
Right, right, right. With
Yes.
Python, it will be easier to develop UI also.
Okay. Hmm.
Yeah, with if you're doing in Python, I hope image feature engineering is there in the session also. In upcoming session, we will see some image in the next session on some upcoming session. We'll see this image feature engineering. I guess that is there in the session
Yes.
also. So those things you can try with the OpenCV. Generally, we use in Python.
Yes, sir. Because
So
that is a
through
good thing. Because
yeah,
what
right.
already we have done with MATLAB, so now I find more friendly the MATLAB. But actually, one should go with Python, so because it's
Yeah.
open CV. And actually, to begin with all these things, I have started my Python exercises. But
Uh-huh.
the way you are so habitual and so frequent with all those downloading the directories and all those things, so it made me wonder that how long probably I will take to understand all these things because importing the libraries and all those things, understanding the syntax. So it is similar to MATLAB, but it is having a method differently it is presented. So that is
Actually,
what.
it will not take any. It will not take so much time, right? Because nowadays, for anything, you are not required to go to library, right? So suppose if you're just working on a particular thing and you are facing any problem, you can just open a Google and then can search for it, right? So a
Yes.
lot of
Mm.
answers you can get, and that will help you a lot. So
Okay.
it will not take so much time to go through it
Yes. Even.
process, right?
Yes.
So
Yes.
don't worry
Yes.
about it.
Okay, will try whatever I'm
Uh,
doing with MATLAB. I will try with also with the Python. So that was actually I was lucky to have
right,
this
right,
link
right.
for my workshop agenda. I was looking forward for pattern. I have
Mm-hmm.
even taught this pattern recognition, sir, and I have
Mm-hmm.
so I'm finding it more interesting the way people are taking the pattern and all those things. I don't know the anchor probably is listening or not, but
Yeah. Yeah,
yes,
ma'am. Yeah.
yes, the workshop is really very
Thank you,
good,
ma'am.
sir.
Thank you, ma'am.
The workshop is really very good because in
Yeah.
Right.
2010 actually we had one workshop wherein we had introduced this pattern recognition along with your basic MATLAB and with Simulink and
Right.
Dr.
Right.
Abhyankar sir from Pune, and we had some 4 to 5 very like Nanded College we had Talbar sir and
Uh-huh.
Subramaniam
Right.
from Walchand Sangli. So they had come along.
Ma'am, in next session means 7 to 12 December, we are adding two session for pattern recognitions. So that will be also interesting one. Okay. Any queries then, participants?
Yeah, there's a query like, can we? Yeah, we can increase the number of
Ah,
neighbors, right? We can increase definitely.
Right,
Definitely,
right.
you can increase the number of neighbors, right? You can just see over here. But the thing is, if suppose you increase the number of neighbors, suppose you're getting a good accuracy at number of neighbors 5, and then you're getting a same level of accuracy at number of neighbors 7 or 10 or 20. Okay, so in that case what will happen, your processor will work more, right? Suppose you are getting an accuracy, suppose 97% accuracy at 5, and 97% accuracy you are getting on 15, and you decided, no, I will choose 15, I will not go with 5. Okay, so in that case what will happen, your processor needs to work more. Okay, so if your processor needs to work more, that means your model is now consuming more amount of power. Okay, more amount of power means what? More expense. More expense means your model is not that much economical. If it is not economical, that means it is not good to deploy for the practical uses. That's why whenever we create a model, we need to look into so many things. We have to look into the like accuracy, like the accuracy should be good, the error should be less, as well as it should if it can consume as less as resources. Okay, that means we have to make sure that it should not consume like maximum resource. If with a minimum resource of use, it is giving you the maximum accuracy, so that is the best possible thing that we can create. That's why less number of you can say neighbors you should choose with maximum accuracy, right?
Sir, I have a question, which means like according to the graph, we need to choose, I mean the K value, where
Mhm.
this training and testing, these lines are meeting, right? For
No,
an
no,
example,
no.
I can see 4 to 6, 5, and which is
Mhm.
reaching somewhere greater than 97, right, sir?
Right, sir. Right, ma'am. Actually, it is not just meeting, right? If suppose it is not meeting, it is very close, then also it can be selected. Okay. In every case, it will not meet. Okay. There will be so many cases where it will never meet, right? But it will be very close. Okay. Like if you draw in this case, okay, you can draw for this case also, other case also. You'll see that they in so many cases it will not meet, but it will come very close. For example, it is coming close over here. Okay, so when it is coming very close, then also it can be accepted, but it should not be very far. Okay, it should not be like one is at 90% and like it was there in decision tree classifier without using any stopping criteria. When we had not used any stopping criteria, what was the condition? Like training was 100%, testing is 81%. So that was difference is not acceptable. But if one is at 95, second one is at 93, 90, even 90 is there, up to 5% differences. 5 is also very, actually a big number, but it's still up to 3 to 4% of differences we can accept.
Sir, I have a like other last question.
Mhm.
Sir, I was like doing this experimentation parallelly with you when you were running the code. So I found that when I was writing this code, I mean from sklearn dot, while I was fitting my model,
Mhm.
like without splitting the data, like train and test without
Mhm.
splitting it, I
Mhm.
was trying to fitting the data, I got this error, like value error. So what are the possible reasons of getting this error, and how I can get rid of this error?
Uh, where it's like just X and Y you just try to fit after this, right? Just a minute. After this, huh?
Sir, where you define this x and y, and
This
then
one, this one.
like um uh,
Is
uh,
it?
uh, uh, sir, line number 20th.
Okay, after this, right?
Yeah, but I didn't split it the data. I tried like the with the first case where you didn't split it the data. It was showing value error.
Value error generally it shows when there is no there is two condition, either X and Y is having no value, or X and Y is having different shape. Shape means what? You can check the shape of it, X dot shape. Okay.
Yeah, it is. It was showing found in input variable with inconsistent number of
Mhm.
samples,
I'm telling
150
you.
and 4.
I am telling you why dot save. Okay. So what it is showing, it is showing like 1797, 1797. That means both are having equal number of sample. So this second entity can be anything, but this first entity should be same. Okay, number of samples should be same. If number of sample is not same, that means somehow you pick the data in a wrong way. So you might have here you are using data, but here you are using something else. It must be you are using target names or something like that. You should use target over here.
Okay, thank you, sir.
Yeah, right. That means you should, whenever this kind of things happen, just check the shape. In the shape, both should have equal number of sample. If both are not having equal number of sample, then obviously training can't be done. Right? Like you are passing 100 features and you are passing 4 labels, then no training can be done. If there are 100 features, then 100 samples you are passing, then in the labels also there should be 100 labels, isn't it? Get my
Thank you so
point?
much, sir. Thank you.
Yeah, right. Okay, so you can go through it again, the code, and if having more doubts, first of all, we'll discuss the doubt tomorrow, and thereafter we'll proceed for the next part, right? Okay, so shall I sign off then?
Okay, Bipul then.